Hello student, here is the question that 360 watt and 120 watt light bulbs. So these three are identical bulbs. So you can say the resistance of each bulb will be same. That's R, that's R, that's R. Here rating is given to you, and that R can be calculated by the formula V square upon P. Okay, so resistance of each bulb will be, that's equal to 120 into 120 divided by 60. Okay, from this rating you can calculate the resistance of this each bulb. That will come out to be, it will cancel out by 2 times, so that's equal to 40, that's 40 ohm. Okay, so V square upon P, so that's a 120, no, that's a 120, that's 120, so it will not be 40, it will be equal to, just write it. So here is the 120 will cancel out by 2 times, that will be equal to 240 ohm. So resistance of each bulb is 240 ohm. Okay, now solid. So here is the one bulb you have, that's one bulb, that's another bulb, connected like that. So if the resistance of each bulb does not change with current, resistance is constant, that's equal to 240 ohm. Okay, it's not changing, it's constant. To find out the total power delivered to the 3 bulb, so total power you have to calculate. Okay, so you can see over there, that's current in this circuit will be equal to, that's 240, and this resistor is also 240, and this resistor is also 240. I'm just simplifying that with, that's battery is connected, that's 120 volt, here is the 120 volt, that's a 240, and that's a 240, here is also 240. So here the total resistance will become, both the resistance are equal, so you can see R equivalent is equal to R of this equivalent resistance of that is equal to R1 R2 upon R1 plus R2, R1 R2 upon R1 plus R2, 240 into 240 upon 240 plus 240, that means 2 into 240. Okay, so it will cancel out and it will be equal to 120. Okay, so 120, here is the 120 and here is the current which you have, that's I. Okay, so circuit will be like that now, that's 240 and 120, and here is the battery 120 volt. So current in the circuit will be equal to, that's current I is equal to potential difference across the resistance, EMF of the cell upon total resistance, that's equal to 240 plus 120. Okay, so that will be equal to 240 upon 636. Okay, so it will cancel out by 1 by 3 ampere current in the circuit. Okay, so here is the current is 1 by 3 ampere. Okay, so here is 1 by 3 ampere current you have, and you can see that these are the equal resistance, so current will equally divide in this, so it will be 1 by 6 ampere, and here in this 1 by 6 ampere. Okay, so now you can take out the total power. What is the total power? P equivalent can be written as power in this resistance will be equal to I square, that's I square into R, and resistance of R is same for both, for all the resistance, that's 240. Okay, plus here is 1 by 6 square into 240 for this one. Okay, now you can you can I square, again you can write for this one I square into R, that's a 240. Now you can solve it out, you just square is this one, so you will get the 240 is common here, and you will get 1 upon 3 square, that's equal to 9, and that's equal to 1 by 36 plus 1 by 36, and that will be equal to 36 plus 36, you can solve it out, you will get the 2 into 36, so that's equal to 240 into 1 upon 9 plus 2 by 36, that's equal to 2 by 36, and that's equal to 1 upon 18. Okay, so that's a 1 upon 18. So again solve it out further, you will get that's a 240, and that's a 1 upon 9 or plus 1 upon 18. Take the LCM 18, you will get here, that's a 240 into 3 divided by 18. Just cancel it out, you will get the 6 times it will cancel out, and from 6 240 will cancel out by 40 times, so 40 watt. Okay, so net power of net power, total power delivered to these 3 bulbs will be equal to 40 watt, and it matches with your option number 3. Option number 3 is the correct answer of this question. Okay, thank you.